Now let's take the next topic, which is circle constructions. What do we mean by circle constructions? By circle constructions, we're going to see how to draw a circle using the given data. Why should we learn about circle constructions? By learning about circle constructions, we will be able to circumscribe or inscribe a circle on a given regular polygon. Also, we will be able to draw external tangents to a given circle. We will also be able to draw a circle passing through two given points, and also we will be able to draw a circle passing through a given line at a given point and also passing through another point. Now, how do we do circle constructions? We are going to see this step by step as we move ahead with the chapter. Now, the prerequisites for this topic are: you should know how to draw the perpendicular bisector of a line segment, then to draw the angular bisector, also to draw a triangle with the given measurements. You must also know that in a regular polygon, each interior angle is equal to 2n minus 4 into 90 upon n. That is, in a regular pentagon, each interior angle is 108 degrees, and in a regular hexagon, each interior angle is 120 degrees. Now let's start with the problems based on this topic. We take the first type, that is, to construct tangents to a circle from an external point. Let's take the first problem here. Draw a circle of diameter 12 cm. From a point P, 10 cm away from its center, construct a pair of tangents to the circle. Measure the length of the tangent segments. Now we want to construct this. First we will have to draw a circle and then the tangents to the circle. So let's start solving this. We first draw a circle of diameter 12 cm, that is radius as 6 cm, and take O as its center. Now we want from the point P, 10 cm away from the center, we want to draw two tangents to the circle. So we take distance OP as 10 cm. Now mark M as the midpoint of OP, that is, we draw the bisector of OP. Now with M as center and PM as the radius, draw a circle touching the original circle at the points X and Y. Now join PX and PY. These two are the required tangents. Now measure the length of PX and PY. We get it equal to 8 cm. Now let's take the next problem. Construct a circle with center C on AB equal to 6 cm as diameter. Mark a point P on AB produced so that CP is equal to 7 cm. Construct the two tangents PQ and PR to the above circle, touching it at Q and R. Measure and record the length of QR. Now let's draw this. Here, first we will draw a circle with center as C, and we take the radius as CA or CB, that is equal to 3 centimeter, because here we are given length of AB as 6 centimeter. Now we produce the diameter AB to the point P such that CP is equal to 7 centimeter. Now bisect CP to get the midpoint M of CP. With M as the center and the radius as CM or MP, we draw a circle to intersect the previous circles at Q and R. Now join PQ and PR. These two are the required tangents. Now join QR and measure and record the length of QR. Now let's look at the next problem. Draw a circle of radius 4 centimeter. Draw two tangents to the circle so that the angle between them is 60 degrees. Now here first we draw a circle of radius 4 centimeter with center O. Now we draw two radii OA and OB such that the angle between them is 120 degrees. See, here we want the angle between the tangents to be 60 degrees. Now let's imagine a quadrilateral. If we have two angles as 90 degrees, because we know the property radius is perpendicular to tangent, and we are taking OA and OB as the radii of the circle. So the angle between the radii and the tangents will be 90 each. So in that quadrilateral, we have two angles as 90 degrees. And the angle between the tangents should be 60 degrees. So we take that as 60 degrees. So what should be the fourth angle? It should obviously be 120 degrees, because we know sum of angles of a quadrilateral is 360 degrees. So we take OA and OB, the radii of the circle, such that angle AOB is equal to 120 degrees. Now we draw the perpendiculars to OA and OB. Produce that, let them meet at a point P. Also draw the angular bisector of angle AOB. That will again meet at the same point. We mark that as point P. So we have got the tangents PA and PB, which includes an angle of 60 degrees. Now let's go to the second type, that is circumscribing a circle on a regular polygon where n is 3, 4, 5 or 6, being given the length of the side of the polygon. Now we are just going to deal with regular polygons. When n is 3, a regular polygon means an equilateral triangle. N is 4, it means a square. N is 5, we have a regular pentagon, and n is 6, a regular hexagon. So let's take the first problem in this type. Using ruler and compasses only, draw an equilateral triangle of side 5 centimeter and draw its circumscribed circle. Measure the radius of the circle. Now let's start solving this. First we will draw an equilateral triangle of side 5 centimeter. Now we know how to draw an equilateral triangle. Now we want to circumscribe this triangle, that is to draw the circumcircle for triangle. So we bisect the sides BC and AC. Let the perpendicular bisectors meet at the point O. Now with O as center and radius OA, OB or OC, we draw a circle. So we get the required circumcircle passing through the points A, B and C. Now to the next problem. Construct a circle circumscribing a square of side 5.9 centimeter. So in this first, we will obviously draw a square of side 5.9 centimeter. Now draw the diagonals of the square. Now join the diagonals PR and QS which intersect at the point O. Now with O as the center and OP as the radius, draw a circle passing through the four vertices of the square. So we've got the required circumcircle. Now let's consider our next problem. Construct a regular pentagon with side 4.4 centimeter. Draw a circle circumscribing the pentagon ABCDE. Now we need to draw a pentagon and on that we need to draw a circle. Now let's first draw the pentagon. We know that in a regular pentagon, each interior angle is 108 degrees. So we will draw the side AB of 4.4 centimeter, then mark 108 degrees at angle B. Then cut an arc of 4.4 centimeter, mark it as point C. Again at C, we mark 108 degrees and so on. We complete the regular pentagon ABCDE. Now, we want to circumscribe this pentagon. So, we draw the bisectors of AB and BC. Let them meet at the point O. Now, take OA as the radius and draw a circle passing through all the vertices of the pentagon ABCDE. So, we've got the required pentagon and the circle on it. Now let's look at the next type, that is inscribing a circle on a regular polygon with n as 3, 4, 5 and 6 being given the length of the sides of the polygon. Now construct a circle inscribing an equilateral triangle of side 6 centimeter. So here first we will draw an equilateral triangle of side 6 centimeter. Now we want to inscribe a circle in this triangle. So we will draw the angle bisectors of angle B and angle C. Let them meet at the point I. Draw a perpendicular from I to BC. Mark that as point M. Now with IM as the radius, draw a circle. This will be the required circle in the equilateral triangle ABC. Now let's look at our next problem. Construct a square of side 3 cm. Draw a circle inscribing the given square. So here, first we will construct a square PQRS of side 3 cm. Now we want to draw the inner circle for this square. So we will first draw the diagonals of the square. Let them intersect at the point O. Now from O, we draw a perpendicular to PQ at point M. Now with O as center and radius OM, draw a circle. This is the required inner circle for the square PQRS. Now our next problem says, construct a circle inscribing a regular pentagon of side 5.5 cm. Now here we will draw a pentagon of side 5.5 cm. We remember each interior angle for a regular pentagon is 108 degrees. So first draw one side of 5.5 cm. Then draw the angle as 108 degrees. Then that side of 5.5 cm, angle as 108 degrees, and so on. Complete the regular pentagon ABCDE. Now we want to draw the inner circle for this regular pentagon. So we will draw the perpendicular bisectors of the sides AB and BC. Let them intersect at the point O. Now OM perpendicular to AB. Now take the radius as OM, draw a circle. This is the required inner circle for the pentagon ABCDE. Now let's have a look at our next problem. Construct a regular hexagon of side 6.2 cm. Draw a circle inscribing the hexagon. Now here we want to draw the hexagon. So we will first draw a circle because a hexagon has the property that the side of the hexagon is equal to the radius of the hexagon which is circumscribing it. So we first draw a circle of radius 6.2 cm. Now mark any point P on the circle. Cut an arc of 6.2 cm on this circle. Mark it as point Q. Now at Q, from Q, cut an arc of 6.2 cm again. Mark that point as R. Again from R, we cut an arc of 6.2 cm. Mark that point as S, and so on. We will complete the hexagon PQRSTU. So we have the regular hexagon. We could also draw this using the alternate method. That is, draw PQ as 6.2 cm, and we know that each angle of a regular hexagon is 120 degrees. So mark the angle Q as 120 degrees. Cut an arc of 6.2 centimeters. Mark that as point R. At R, draw angle 120 degrees, and so on. Complete the hexagon. You can use any method to draw the hexagon. Once we have the hexagon, we want to inscribe a circle on it. So we will draw the perpendicular bisectors of the sides PQ and QR. Let them meet at point O. Now OM perpendicular to PQ. So take the radius as OM, draw a circle inscribing the regular hexagon.